Hello everyone. Today you will learn how to find B induced by a current. At the end of this session, you will understand the law of Biot at Savar and Ampere's law. Both are used to find the magnetic field induced by a current. Now, to find the direction of the magnetic field turning around a straight wire, you use the right-hand rule with the curved fingers, where you put the thumb on the current direction, and a magnetic field direction is circulating around that current along your right-hand rule. Now, if the current is circulating, then the curved fingers are going with the current, and B induced would be on the thumb direction, and you always use the right-hand rule. Now, if the electric wire is carrying a current of intensity I, and your house or the point P where you're measuring the magnetic field induced by that current is at a certain distance d, like in the first figure, the magnetic field magnitude on the house is given by the formula mu0 over 2 pi is the constant, I is the current, it is proportional to the induced magnetic field, and it is inversely proportional to the distance d separating the current and the point P where you're measuring B. Now for a loop, if the wire is a loop, so the magnetic field is given by mu0 I over 2r. What if it is a solenoid, يعني a certain number of loops بيصير mu0 times n over L length of the solenoid times I. Now in the second slide we will think about the direction of this magnetic field induced by the current. Now to find the direction of the magnetic field induced by a straight wire, you put the thumb with the current I. You will find that your fingers at the house are pointing to you. That's why it is represented by a dot direction. So it is out of the page. Now, if you go to the second example, for example, the current is circulating, so you put your fingers of the right hand circulating with I, you will find that B induced is of your thumb, يعني direction of your thumb is into the page, that's why you put it as an X. In the last example, for the solenoid, you put your fingers with the current I, they are circulating on the loops, so if you find the thumb is going from south to north, so the magnetic field inside the solenoid is directed this way. Okay, you can practice by inverting the current's direction. If the current in the first figure is going left, again you repeat the curved fingers right hand rule إذا بدكم. You take it to the left, your fingers are going into the page in the first figure, so it is an X. If you go with the second figure, your fingers are curved with the current, so B is a point, it's pointing to you. And if you take the solenoid and the current is going down, you put your fingers curved with the current, so the magnetic field is going right. We still have one example اللي هو التورويد. It's just like a bracelet وحواليها we have the blue wires هن current are carrying some current, and the toroid, to find the B induced inside the toroid we will use Ampere's law that you will learn later on. So remember إنه ال B induced هي هيدا in yellow mu0 and I over 2 pi I. The direction, as usual, you put your hand with the current that is circulating, and you can find the B induced inside the toroid. Now let's study law of Biot and Savar. When you have a wire carrying a current I and a certain point P at a certain distance R from that wire, and you want to find B induced by the current at point P. dB is defined as a vector by the formula mu0 over 4 pi, which is a constant. بالنumerator I have a cross product اللي هو between the current and the vector R over R to the power 3. Now what is ds and what is R vector? ds vector هو a small part أو a small element of the wire, so it is a vector tangent to the wire. and since the current is not a vector, ds is showing the direction of the current. هلا ال R is a vector relating أو pointing from ds to the point P، يعني من السبب للنتيجة from the cause to the effect from ds to the point P where the magnetic field is created or induced. هلا if you simplify من النumerator والdenominator by R، remember إنه فوق ما بيبقى لي 1 بيبقى لي الunit vector UR which is the magnitude of UR is 1. Yes, correct. هلا if you want to find the magnitude of dB بتصير IDS times 1 لأنه الunit vector عنده magnitude 1 times sine الangle between DS and UR. And of course if you want to find the B total you have to integrate dB. So will be created by the whole wire, you have to integrate all the dBs, يعني all the ds. In this slide, I'm giving again the magnitude of B induced by a straight wire and by a loop. هلا if you have a part of the loop يعني a certain angle, so you find phi over 2 pi يعني mu 0 over 2r اللي هي the magnitude of the magnetic field created by a whole circle, and mu 0 I phi over 4 pi r لأنه كأنكم زدتوا phi over 2 pi اللي هي a fraction of that circle. We made an experiment where we put two parallel wires and we saw that they are attracting or repelling each other. This is due to the magnetic force F, where you know that when a current is placed in a magnetic field area, the interaction between the electric current and the magnetic field is creating a force F magnetic. هلا هون when I have two wires حتى إذا ما في external magnetic field, one of the wires is creating a magnetic field on the other one. So is the other wire يلي هو the second one مثلا is undergoing a force لأنه the interaction between the current of this wire with the magnetic field of the other wire and vice versa. And you can find the magnitude of F لأنه ال B is induced by the other current. هلا in this formula 90 منين إجت؟ It is the angle between the current and the magnetic field. So you have to find the magnetic field first due to the current, the other current, and you use to find it you have to use the right hand rule with the curved fingers, and then to find the force of magnetic you have to use the three fingers اللي هي تبعية الcross product. اثنيناتهم right hand rule بس ال B induced مع ال curved fingers ال F هي مع ال three fingers. You put the current on the thumb, ال B on the index, and the force would be on the other fingers. Let's start with a quick summary. For two parallel wires, and we have the current going upward in both. So think about the magnetic field created by one wire on the other. ما حدا بيقدر يعمل magnetic field على حاله، اوكي؟ سو مثل الدفاية بالشابتر 22، الدفاية بتدفي حدا بس ما فينا ندفي على حالنا، لأنه if you look at the Savar's formula في بقلبها بالدينومينيتور في عنا r squared، so r is different than 0. ما حدا بيقدر يعمل magnetic field على حاله. So مثلا إذا عم بحكي عن الكيرنت الأخضر it should make a magnetic field على الأحمر. So place your thumb on the green wire, okay, and your fingers on the red, curved fingers on the red, okay. رح يكون point ال B الأخضر رح يكون point. So على الأحمر حنرسم B أخضر جاية من ال I2, it's a point pointing outward out of the page. If you repeat the same for magnetic field created by I1 on I2, so you put your thumb on I1 والمagnetic field اللي عم بيبرم حواليه لل I1 رح يكون going into the page على البوزيشن تبع الجرين. So the magnetic field turning around the current 1 is going into the page on the right side of the I1. That's why ال B الأحمر هو على الجرين. And if you think about the source of the magnetic field الجرين هو حيكون current in green كمان. Okay? So if you put your thumb on I2 going up, على left side your fingers are going towards you. So لازم يكون a point. هلا what is the force since عندي current وعندي B at the same time okay and they are interacting with each other لأنه عاملين a certain angle so حيكون عندي mechanical force F اوكي أنا سميتها mechanical لأنه هو شيء الفورس دايما هي شيء mechanical بس actually it is created by the current and the magnetic field so بتتذكروا الفورمولا تبع الفورس magnetic هي IL cross B which is ILB sine theta and the angle between the current and B is 90 degrees so هي ILB Now use the three fingers right hand rule تبع chapter 28 if you put your thumb with I2 for example الB هي cross into the page the force would be on the left the all fingers will be on the left now if you think about I1 كمان going up but B is pointing to yourself so F will be going to the right your hand is a little bit twisted هلا مزبوط الفورس هي ILB واتفقنا الانجل is 90 بس ال B itself is induced by a wire والstraight wire formula of B induced هي mu 0 I over 2 pi D هلا في عندي current I عم بيعمل interaction مع magnetic field جاي من ال 2 so رح يبين عندي ال current 1 and 2 so إذا بتقلبوا الفورمولا إذا بدكم تجيبوا ال F2 ما رح تفرق شيء لأنه same length same distance separating the two wires same constant mu 0 over 2 pi وإذا عملنا I1 times I2 ولا I2 times I1 ما فرقت that's why I can say إنه الاتراكشن هي ذاتها same force magnitude F1 and F2 So we already saw that if the currents are going with the same direction رح يعملوا attraction حتشوفوا two currents عم بيقربوا على بعض two wires بلشوا يعملوا attraction لبعض كأنهم magnets إذا كانوا الماجنتس إذا كان الcurrents in opposite direction in each wire مثل ما هلأ رح نشوف أكيد you expect that they would repel each other so let's prove it and find the magnitude again so what do you think the magnetic field is going how on each wire use the curved fingers rule with your hand right hand so if you put your thumb with I1 على right side of I1 the magnetic field is going into the page so بحط X و if you put your thumb على الجرين I2 is going down كمان حتكون X on the right side of I2 so the magnetic field 2 is going into the page as well. Now think about the direction of the force. So for example, if I am thinking about the green I2, I have to use B1. So I2 is going down, you put the thumb down. B is going into the page, the force is going to the right. If you think about I1, you put I1, the thumb is going up. You put the index going into the page لأنه هي representing B and the whole fingers would be going to the left على current I1. So the force على 1 is going to the left. This means the two wires are repelling each other. Again, put a pause. Please think about the direction of the force on your own. Never rely on what I am saying. Please always check the answer and try to solve the problem on your own. Again, if you find the force in magnitude, you will find the same F mu 0 over 2 pi I1 I2 L over D. So the second objective of this chapter is to find out to understand Ampere's law. It is used to find the B induced by a current. Okay, so to do that, you have to draw an Ampere's loop. Usually it is either a circle or a rectangle, and it is measured in meter, sorry. B, the magnitude of the magnetic field is measured in Tesla. I enclosed in Ampere. So what is Ampere's law? هي إنه الانتجرال of BDL scalar product is equals to mu 0 times I enclosed by that loop. Okay, with DL is a small element of the loop. Okay. Let's apply Ampere's law on a straight wire pointing out of the page. If you use the right hand rule with the curved fingers, you will see that the loop is rotating, our B is rotating in counterclockwise. هلا you show me ال B and you put إنه ال loop is rotating with B يعني ds اللي هي a part of أو an element of the loop. هلا مرات بتسميها dl مرات ds it's the same. إنه المهم it's a small part of the loop هي مع ال B. So the angle between them is 0. So ال scalar product ببطل integral B scalar product ds خلص بتصير B ds لأنه ال angle is 0 وال cosine 0 is 1 equals mu 0 times I enclosed by the loop. اللوب هي الراد circle. اوكي so you place ال I total تبعها بتصير mu 0 I over 2 pi r هيدي ال B. ليش؟ لأنه ال parameter of the loop هو 2 pi r بتروح لتاني ميلة من ال equal بتصير mu 0 I over 2 pi r. هلا if you are inside the straight wire بقلب ال cross sectional area B is equals to mu 0 I over 2 pi r squared times small r والsmall r is smaller than big R لأنه you are finding a part of the backbone of the current يعني I will prove it in a problem later on. For example, in the figure on the right, the loop is a little bit, the Amperian loop is not a circular one, but it is more إذا بدكم random. هلا ال I enclosed are only I1 and I2. ال I3 مثلا is not enclosed by the loop. That's why you don't put it in the formula. So let's start with الانتجرال BDL equals mu 0 times ال I enclosed اللي هي الفورمولا تبع Ampere's law. And we will prove at the end إنه ال B magnetic field can be derived from this formula and it will be equals to mu 0 times the number of loops divided by the length of the solenoid times the I current passing through the loops of the solenoid. Now let's apply an Ampere's path اللي هو in green dotted line. Okay, it's a loop, a rectangular loop. عندها 3 DL, DL1, DL2, DL3 and DL4. And if you integrate BDL on each side of this rectangle, it is equals to mu 0 times I enclosed. هلا BDL2 and BDL4 are equals to 0 لأنه they are perpendicular to each other. So a scalar product would be 0. And BDL3 is also 0 because B tends to be 0 if you are very far away from the source of the current. مثل كأنه السولينويد ببيروت وأنا بالشمال. So it's very far from me. The effect of the current is negligible. So I consider it as 0. The only one is integral BDL1 that is not equal to 0. اللي هي ال B inside the solenoid that I am searching its magnitude. هلا integral BDL1 it is equals to BDL1 لأنه ال cosine is 0. The angle between the magnetic field and DL1 is 0. Then B بتطلع برات الانتجرال because it's a constant. بدلل لي integral DL1 which is L length of the solenoid equals mu 0 times ال I enclosed هي how many loops I have. Each one has a current I. So أنا ما كأنه loop وحدة عم تعمل لي magnetic field كذا loop. So each one is creating a magnetic field. So المنطق إنه it is proportional to مش 1I to Ni. And if you want to take L to the other side بتصير B equals mu 0 N over L times I. Or you can replace N over L by small n. Okay, remember the purpose of this problem. It's always to find the B induced by a current. هلا الكيرنت إذا مثل ما انكم شايفين بالفيجر A in blue هو عم يبرم على التورويد والتورويد is different from the solenoid. السولينويد هو لوبس حد بعض بينما هيدا اللوبس مبرومين as a circle. هلا since الكيرنت بعرف الدايركشن تبعه I can guess كمان الدايركشن of B. The problem is not to find the direction of B, it's more about the magnitude of B. لأنه direction is known. ودايما إذا لاحظتوا اللوبس الأمبيريان loop is always directed with B. ليش؟ تيكون الانجل 0 وقتها بدي حل الانتجرال B scalar product مع ال DL بيطلع لي B DL cosine 0 تيكونوا 1 يعني الكوساين 0 is 1. مشان هيك انتو البي بتطلع برات الانتجرال بتصير بي تايمز قديش الدي ال كلها سوا. الامبيرز لوب هون it's in orange. So you can see إنه هي circumference 2 pi r equals mu 0 I n لأنه I have n terms بالتورويد. اوكي وكل current عم بيعمل لي magnetic field. So that's why I multiply to find the I total enclosed هي n times I. هلا to find the B it's easy لأنه you take 2 pi r لتاني ميلة من الإيكوال وخلصت.